So today we'll talk about the sampling design. That is a very important step, as we say here, is a proper planning design of the study area is vital for collecting relevant and useful data. Because if we will properly design our sampling, we can use the data in many kind of analysis, or specifically for our target species for a specific analysis. At the opposite, in contrary, if we don't design our sampling properly, we will have a lot of limits on that analysis. So, what is the target species? We can have a big one, we can have a small one, and depending on the species, clearly will depend on design, on the size of the species, but also from their home range, so from their density, as we will see. In our case, we know that we are working for Manu working group, that we are member of Manu working group, then many of us working on Manu, and sometimes we overlap the study area with the snow leopard territory, so many of us study both species. So we had to look at the species size and the ecology, but also if we had to sample for a single season or multi-season, and if we are in one area, or if in a place we may have two isolated mountains, for instance, where our cat, small and big, will live, and then we can cluster our cameras or our interview, because into cluster, like here in the map. I say our camera or our interview. Why? Because you will see, I will recall this concept when in the next lesson we will talk about the interview-based survey, that the same thing we use for cameras, we can consider also for interview when we sample, design our sample. Very rarely the interview-based survey is conducted under a sampling design, but we will see it will be very useful. So, go straight to our species. The Pallas cat. What can be a first thing? How to set the camera? It depends also from our research question. For instance, if we want to estimate the species density, we need to identify the individuals. Then we set the camera traps for Pallas cat just behind the marking point, so that when he get under the shelter where he used to mark, he will watch at the marking point. I will watch to our camera, and then we can identify the spot here. And then through that we can understand which individual is, identify the individuals, basically. With large cats, which is leopard or snow leopard, we need to get mainly the flank, sorry, because they have a specific sure pattern of the spot. So we need the right and the left flank. We can also use the head and the tail, but generally it's much better to use the flank. So we need to put two cameras, one in front of each other, or use the marking sites, because generally there is the big cat arrives, sniff, and then turn, and then mark, and then turn again, and then sniff. So in that way, especially if you have video modes or multi-shot without a delay between photos, we can get 30, 40 photos in the while he's standing in the opposite side and have both flank available. So, as you say here, we're able to compare 4 individuals, for instance, through the spots. Another point is going to strictly to the sampling design is how big should be the sampling area. Then depends from the species. If you have a small cat, like a Pallas cat, probably 25, 100, there is no specific rule. But probably 25, 100 square kilometer will be enough to detect all the whole population, don't miss any cat there, and cover for sure the home range of the manual living there, and if we put, for instance, one camera each kilometer, we probably will not miss any cat. We'll miss some, but we'll not detect all, but we'll detect the most. And the same with large cat. If we have a leopard in a bush full of prey, probably his home range will be smaller and will not move too much, and the sample 300 square kilometer will be enough, will not have bias in that case. But for a snow leopard, the best would be minimum 500 square kilometer, the sampling area, uh, and maybe even larger, for instance, 2000 kilometers to close a full population. So it depends from the species, density, and home range. For the Pallas cat, I will say, based on my experience, 25 to 100 kilometers are more than enough. But let's say 25 to 50 is already very good. So also, are we looking for a single species? In that case, we have to target to detect that species to answer to a research question related to that species. As I say, very specific, especially for small cats. If you do a generic sampling for Pallas cat, you will detect 4 or 5 detection in a season. If you do something specific, like I said, we detect even 100 of Pallas cat using 45 cameras in a season. Pallas cat detection, not individuals, but 20 individuals. So if instead you look at multi-species, for instance, you want to see how a prey affect the occupancy of a snow leopard, in that case, it would be better you stratify a bit the sample, but you can find the strategies. For instance, if the mountain where you are working has ridges, not too steep, not too high to ridge, then you reach the ridge in a saddle, you will likely see there is marking of snow leopard there, but at the same time there is footprint of ungulates. So you will detect many snow leopard who pass from the saddle and mark there, and many prey. So in that case, you can somehow stratify the sample. With the Pallas cat, it's a bit more difficult to do that, but anyway, I can say that the preferred species of Pallas cat obviously overlap their habitat with Pallas cat, like Pika, but also in Mongolia, the Mongolian silver ball. So probably putting the camera under the shelter, you will detect, as happened with in our case, both the Pallas cat and also the prey. Then the size, we say if all this sampling area will be, let's say, pretend is 500 square kilometer, each cell in the grid must be 4 kilometer per 4 kilometer. Whereas in the Pallas cat, I would say it is going to be 1 kilometer per 1 kilometer, no more than that. Why? Because we have to be able to detect, if possible, all the cats passing from the cells, not missing one if possible, but avoid the autocorrelation, which means detect the same individuals in a camera which walk for 500 meters, and after 50 minutes you detect the same individual in the same passage in another camera just 500 meters far. So in that way, I account in my analysis 2 times the same passage, which will be a bias in the analysis. So to avoid that bias, I have to put the camera far enough. I have to say, based on my experience with the snow leopard, honestly, 2 kilometers are enough. In many years, many cameras, many data, I never got a leopard passing in a camera, and after, let's say, 1 hour, 2 kilometers far in another camera. Never happened. I'll get detected a day later, many days later. And there was hypothesis, I think, many hours later, but not just passing on the same road. Even two cameras put 2 kilometers in a good road never detect the same leopard, snow leopard in that case. However, the best rule is keep this 4 kilometers so we are safe to detect, to cover the smaller female snow leopard home range, which is approximately 16-20 kilometers, and avoid the autocorrelation to get the same individual as I explained just to the next camera after a few minutes. And the same will be, sorry, for Pallas cat. We detect the Pallas cat in a camera, put 1 kilometer, for sure you will not detect it after a short time in the next camera. Even because in the case of Pallas cat, you generally they don't use easy pathway, trail, roads, passages. They go through the rocks. So really difficult to find from a shelter to another shelter the same cat after a short time. So remember, keep the minimum distance. I will say 1 kilometer for Pallas cat, 800 meters is fine, and try to do the grid as regular as we can. We will see later how to build a grid like this in QGIS, which is an open source program, so no payment. Then you have to download it. I will teach you how step by step do an appropriate grid and sampling design using QGIS. We can do also this kind of grid, which is not a grid. Why? Because we do opportunistic sampling, just arrive and put the camera wherever we think. In this case, please keep at least the minimum distance, so avoid the autocorrelation. Or really our analysis will be too limited. But nowadays, in the model, the model take into account for non-regular grid. Example, with the traditional capture-recapture, you need really a regular grid. With the spatial capture-recapture, if you don't have a regular grid, the model is still stable. Work, in other words. So even you have, for instance, let's say a peak between these two lines of camera, so you cannot reach there, and you dispose your camera in this way, still, with a spatial capture, it can work. If possible, would be better if you keep that minimum distance of 4 kilometers, if it's not possible 3, or maybe even 2 sometimes. But remember that the best is a regular grid with the proper distance between cameras. If you really cannot, you can try something like this. Other question is, do you know the area? Because if you know the study area, basically no need to do anything else. Then take your camera, go there, put one camera, after a kilometer put another camera, after another kilometer put another camera, then try to do a grid, and your grid for Pallas cat is perfect. No need anything else. You know where is the mountain, where is the rocky outcrop, where is the cats. So why you need to work on QGIS? No need. How do network features well define the sampling area? We are in the Great Gobi, where there is a plateau and very few outcrops of mountains. And then we go straight there. We know that the area is already no larger than 500 square kilometers. We take the whole mountain, we put the camera as regular as possible, and we have a perfect sampling design for snow leopard. Or we take 1 kilo, let's say, put the camera each kilometer inside that mountains, we know the Pallas cat is there. Will not be in the plateau, in the flat plateau, desert plateau, surrounding the mountain. So there we have a kind of island on the sea. And we know that the Pallas cat is not ever will be in the island. So no need again take a day before, match a day to study much. Just we can go there and put our camera with the proper distance. But sometimes we don't know the area. And for instance, let's say we have a big mountain chain, but sometimes it's too high, sometimes it's too low, sometimes it's too smooth, sometimes the ruggedness is much higher. So we don't know a priori what we have to do. We go there, we have a 5,000 square kilometer of mountain. It's difficult to take our camera and start setting the camera by luck. It's not possible. In this way, before then go, we have to have a clear idea where we need to go. And not only according to what Herder say, because sometimes Herder live in a place, but just 5 kilometers further, where no Herder live, is full, let's say, of Pallasquetto, no one know, because maybe there is not easily accessible from Herder's area, maybe accessible from another area, so the Herders never go there, but we can go there and find a density of Pallasquetto, also Melbourne. So what we are going to do? How we can do it? Simple. With the QGIS, we use a simple habitat suitable model where we can say, select me please the areas above 1,500 meter and below 2,500 meter. And that's it. Or select me those areas within this elevation range, and also with a slope higher than 5%. We can do that. In that case, we select only that suitable area, put a grid on the top, put the centroid in each cells, put the coordinate of the centroids in our GPS, and then check. Go with our GPS there, say, here there is a point. Look around for that point for 100, 200 meters, and say that there is a good size to put the camera from my Pallasquetto or from my Stone Leopard to detect them. So this is the perfect way, when you don't know an area, to have a higher chance to detect our species. Now we will see with the practice how to do this.